Hello students. Today we will start with reflection. Usually it comes in board exam for 4 marks, and in this topic we will be covering all the important concepts, and we will also try to do latest board questions. Concepts शुरू कर देते हैं. Let's start with reflection. We have already drawn the axis. Let us write this as x-axis. And let us mark some points on x-axis. Say this is origin, intersection point. You have already seen these things in your lower standard. Say we take along positive x-axis some points at a distance of 1 centimeter on your graph paper. Now in ICSE exams, the graph paper will be of 2 centimeter scale. So every 2 centimeter will indicate 1 unit to you. Let us take some points on the negative x-axis. -1, -2, -3, -4, say one more, -5. Let's take one more here, 1 along the positive y-axis. You already know these things, so we are doing at least the marking part, and this is your y-axis. Now any point on x-axis, choose any point on x-axis, say of your choice. Say you choose this point, then the coordinate of this point is given by 2, 0. Because it is on x-axis, it is not having any height to it, so the y coordinate is 0. If you would have tried writing the coordinate of point 3, which is on x-axis, again it will be 3, 0. So every point on x-axis will have the y coordinate 0. So the equation of x-axis is given by y equal to 0. I'm repeating the word, I'm even writing it. Equation of x-axis is y equal to 0. Similarly, equation of y-axis is x equal to 0, because every point on y-axis will have x coordinate 0, similar to what we tried explaining here. For example, for this point 4, the coordinate will be 0, 4. So x coordinate is 0, hence equation is x equal to 0. Let us take, say we take a scale, and say we try drawing a line, say like this. Say we draw a line cutting y-axis, say like this. Now this line that we have drawn is cutting y-axis at 2. Then the equation of this line is given by y is equal to 2. So how will you learn equations? If your line is cutting y-axis and it is remaining parallel to x-axis, then the point at which it is cutting the y-axis will become the answer in the equation as y equal to 2. Similarly, if we would have taken a scale here downwards and say we have made a line like this, clearly the equation of this line will be y equal to -3. Let us now take the scale and let's say we make it perpendicular. Just 1 second. Okay, this is the graph that we had drawn. This is the graph. Let's say we make, just one moment. Okay, let's say we make it 90 degree, and this time we will try to cut the x-axis. So we have brought the graph here, and let us say this time we cut the x-axis at 1. Now when you cut x-axis at 1, you are going to get the equation of this line similar to what we have just written a while back for y. This equation will be called x equal to 1, because it is cutting x-axis at 1 and it's remaining parallel to y-axis. So this basic way of writing equation of a line should be known to students. Let's take one more example. So we get this equation as x is equal to -2. This will be also helpful in the next topic when you will learn equation of a line. Let us continue and let us plot any point. Say randomly we plot a point say here, and we name it as say point A, and because it is corresponding to 2 on x-axis and 3 on y-axis, the coordinate of point A is 2, 3. Now the question is that you try to reflect this point on x-axis. Reflection simply means that it is the mirror image. So if the height of this point A from the x-axis is 3 units, then the reflection in x-axis will take it 3 units downwards, like this. So the path of this point is going to be the vertical line when you are reflecting on the x-axis, and eventually let us say it comes at this particular point, we call it as A dash, and then its x coordinate still remains 2, but its y coordinate changes to -3. So when your point A has got reflected in x-axis, you are finding that 2, 3 has transformed to say A dash 2, -3. Every time making graph will become difficult. So let's try to learn mechanically. That is, if you are reflecting a point about x-axis, then the y coordinate will change in sign. So if in general we would have got the point A's coordinate as x, y, then A dash would have become x, -y. If this point itself was negative, then the point of y coordinate after reflection would have become positive, and so on. Let us now focus at this point again, and this time let us try to reflect this point about y-axis. As you know, the point is at a distance of 2 units from y-axis, that is why you have 2 here. Now when you reflect it about the y-axis, you will have to move 2 units on the left. So you will reach here. Let us say we call this point as A double dash. Let us try to write its coordinate. Its coordinate x is -2, while the y coordinate is 3. Let us look at our question. So A has become A double dash. A's original coordinate was 2, 3, and after reflection about y-axis, A double dash is becoming -2, 3. This again indicates that if the reflection is about y-axis, then x coordinate will change in sign. So every time, without making graph, the answers are possible to be derived. Let us now reflect this point A about origin. Let me take one more color. Let me choose say yellow. I hope it's visible. Let's try to reflect this point about origin. So if A is say at a certain length from O, then its reflection about O is going to be somewhere here, right? Let us try to write the coordinate of this point A, say A triple dash. It's looking very light. I hope you can manage this one answer. So reflection of A 2, 3 answer is going to land you in third quadrant, where coordinate is becoming -2, -3. What happened? Yeah, so you have got the thing back. Let me write this here. Let us write that answer here as if A, I'm writing it here, if A gets reflected about origin, then let us say we denote the answer as A triple dash. Then A's original coordinate was 2, 3, which has transformed into -2, -3. So change of sign happens in both the coordinates. So in general, we have learned reflection of a point about x-axis, reflection of a point about y-axis, reflection of a point in the origin, and we have also learned that if a line is cutting x-axis at say 1, then its equation is x equal to 1, provided it is parallel to y-axis. And similarly, the green color lines indicate equation of line parallel to x-axis, but it is cutting y-axis say at 2, then its equation is y equal to 2. Let us continue further. Let us consider one last point, then we will change the graph. Already the graph is having a lot of things. Let us now consider again this same point A. which we have written as 2 comma 3. Now if you are reflecting this point about this line y is equal to 2, which is certainly parallel to x-axis, this is parallel to x-axis, y equal to 2 I am saying. So if this point is reflected only about this green line, then we can notice that this point A is at a height of 1 unit from the green line y equal to 2. So if it is going to get reflected in this green line, then it is going to follow the same vertical path, but it is going to come only 1 unit downwards. So this point, say A4 dashes I am writing, is going to be given by one coordinate down. So already this y coordinate will become now 1 and the x coordinate will continue to remain 2. So 2 comma 3 becomes 2 comma 1. So if the point is getting reflected in the line say y equal to 2, then answer is say A4 dashes 2 comma 1. Now this is very difficult to every time plot and get the answer. So we have a way to remember it. Let's try learning that. If it goes very difficult for you, then you can always sketch the graph and get it. But we would strongly advise you can at least make an attempt for learning this. So if point A, say x comma y, is transforming about the line say y is equal to a, y is equal to 2 means say y is equal to a I am writing, then your point A say 4 dash I am writing will become x comma minus y plus 2a. Let's check whether this formula is really becoming or is true or not. So if your point x comma y was 2 comma 3 as we have in this question, and you have y is equal to 2 line about which you want to find the reflection, then your answer would have become x will remain same. So we are going to write 2 as 2. Then we have minus y, but y was 3. So it will become minus 3 plus 2 times a, but a is 2. So this on calculation or evaluation will become minus 3 plus 4. That will become 1. So that's 2 comma 1. That same answer we were getting for A4 dash here, 2 comma 1. It means that this can do wonders for you if you don't want to sketch the graph to get the reflection of the point about the line say y is equal to a. Similarly, if you have a point say B, x comma y, and you want to get it reflected about the line say x is equal to a, then let us write B dash. The answer will become, it will become very similar. When you are reflecting about y sign changed. So if you are reflecting about x equal to a, then it will become minus x plus 2a, comma, y will remain same. Let's take an example to support this. Say we have 2 comma 3 here, and say the reflection is about x is equal to minus 1. In this case your answer would become of B dash as minus x. So minus x coordinate is 2 plus 2a, but a is minus 1, comma y is same as what it was in the question. So minus 2 becomes minus 4 comma 3. This is your answer. So far we have learned now reflection of points about the axis and also about the lines which are parallel to the axis, like y is equal to a and x is equal to a. Let us take some more examples. Let us take find the reflection of a point in x-axis. Let's take first question for you. Say the point P's coordinate is 2 comma 3 and we want to reflect the point in x-axis. Let me write here mx. M indicates mirrored about x-axis. So we have discussed that the answer of y coordinate will change in sign. So answer will be 2 comma minus 3. Let's take one more example. Say we have P minus 4 comma minus 5. Then the reflection of the point about x-axis is given by say P dash. Y coordinate will change in sign, x will remain same. So answer is minus 4 5. Let us consider one more point, say p phi comma 0. If you reflect this point about x-axis, then this point will not change, it will stay there only, because there is nowhere for it to go down or up, it will stay there only. So answer will remain phi comma 0. Because the answer is remaining same, we call this point P. Point P is called invariant in the third example. Let us now, invariant means it is not changing. Let us now take some examples for the reflection of a point in y-axis. Let us consider a question like P 2, 5. Say it's reflecting or mirroring about y-axis, then P dash will become minus 2, 5, x coordinate sign will change. Let's take one more, minus 4, minus 6. Yes, you can now think and tell. The answer will become 4, minus 6. Let's take one more. Say point P's coordinate is 0, 5. Then when you mirror it about y-axis, it will stay there only. There is nowhere to go because it is on y-axis. So answer remains same. Therefore, in this case, point P is called invariant. Let us now, and in case you wish to do it by the earlier method only, then 0 will become minus 0, but 0 is neither positive nor negative, so 0 would have stayed that way only, and phi as it is. Hence P's answer, P dash answer is remaining same as P. That's why point P can be called as invariant point. Let us now take question where we find the reflection of the point about the line, which is say y equal to a types. Let's take some questions of that type. Say we have to find out the reflection of a line which can be either called as parallel to x-axis or y equal to a. Y equal to a is the equation form. Let's take a question. Let's take an example. Say we have P 2, minus 3 is getting reflected about y is equal to 2. Before we do this, let us try to recollect for you when we tried teaching you Px, y, and if it was reflected about y is equal to a, we said P dash would become x, minus y plus 2a. So P dash answer would become x will remain as 2 only here, minus y. So minus of already y itself in the question was minus 3 plus 2a. A is 2. So 2 times 2. Whatever you get is your answer. So this would become 2, 3 plus 4 is 7. Let us take one more point. Say we have P. Let me take both values negative, and let us take even y as say negative, y equal to minus 1. So P dash would become for us, x will remain as x only, so minus 2 remains as it is. Then you have minus of y, but y in the question is minus 5, plus 2 times a, but a here is minus 1. So this results into minus 2, 5 minus 2 is 3. Let us now take the reflection of the point parallel to y-axis, that is x is equal to a. Let's see what we get by that. Reflection of a line parallel to y-axis. Let us first write the formula and then take the example. This is a recollection of what was already done. Pxy about x is equal to a is given by P dash minus x plus 2a, y. So एक example we can take for this, say minus 5, 2, and it's reflected about say x is equal to minus 1. Then we get P dash, we have minus x, so minus, and then x by comparison is itself minus 5, so minus will come, plus 2 times of minus 1 as a is minus 1, y is 2, as you can see in the left hand side, y is 2. So this implies P dash becoming 5 minus 2 is 3 comma 2. Like that you can explore some more examples. Let us now take our attention to what would have happened if the reflection is about the origin. I think that's easy for us to understand. Reflection about origin. So let's take a question P 2 comma minus half ले लेते हैं. Then reflection about origin, O indicates origin, will be transforming or changing the sign of both the coordinates, which becomes minus 2 comma half. Let's take one more. P is say minus 1 minus 2. It's going to be in similar fashion, P dash becoming 1 comma 2, and so on. Lastly, let us see what would have happened if a point P is going to get reflected in x-axis and becoming P dash, and then from P dash let us transform it about origin. So instead of writing origin and x-axis, let us write, say here, let me write MO, okay, MX and MO. Let's see what outcome we get, and we have the question as say P2 comma 1 is transforming about x-axis becoming P dash, so that will change the y coordinate sign to 1 becoming minus 1, and when you reflect it about origin, both the signs will change of this, which will become minus 2 comma 1. But if you look at the question and if you look at the final answer, if you try to connect the dots, if you try to join, like if you try to interpret the result, then you are finding that the x coordinate sign has changed, which implies that there is a reflection of this point P about y-axis. That is why x coordinate sign has changed. 1 has remained 1 only here. So reflection of a point in x-axis followed by the reflection of the point in origin leads to the reflection of the point in y-axis. Let's take one more example. Say we have P minus 1 minus 5 getting reflected, say, about origin becoming P dash, and then let us say we reflect it about y-axis and we call it as P double dash. When you reflect it about origin, both question having negative values will become positive, and when you reflect it about y-axis, sign of x coordinate will change. It will become minus 1 5. If you try to form a pattern or interpretation, if you want to do about the question and the answer that you are getting, then you are finding minus 1 remains same, but minus 5 is becoming 5. So definitely there was a reflection about x-axis as the change has happened in the sign of y coordinate. Let's start with some problems. Let us take a board question. Use a graph paper for this question. Take 10 small divisions, 1 centimeter, 10 small divisions equal to 1 unit on both axes. Now they have said P's coordinate is 0, 5 and Q's coordinate is minus 2, 4. First question, P is invariant when reflected in an axis. Name the axis. Now this is P's coordinate. Now because its x coordinate is 0, just for a rough explanation, this must be the point 0, 5. Now where will it remain invariant? If you get it reflected about the y-axis, it has got nowhere to go. So where is this point invariant? It is about which axis? Y-axis. If about x-axis you are thinking, then x-axis may you will get a reflection of 0, minus 5. So where is point P remaining invariant? It is remaining invariant about y-axis. So answer is y-axis. You can even call this answer as x equal to 0, as equation form of y-axis is x equal to 0. Next question. Find the image of Q on reflection in the axis found in 1. So this is your point Q. You want to find the image of Q on reflection in the axis. So which axis are they talking about? Y-axis that you have found. So when you find reflection of point Q let us say it becomes q dash, but you want to get it about y-axis. In reflection of y-axis, the point's x coordinates will change in sign, but y coordinate will remain same. So answer for say q dash is 2, 4. Third question, 0, k on reflection in the origin is invariant. Now whenever you are reflecting a point about origin, both the values will change in sign. So we will get 0, k, say this is 0, k, when it is reflected about origin, 0 sign will remain 0 only, minus 0 to nahi likhoge, but k will become minus k. But they are saying the point will remain invariant, so both these answers should be identical. 0 is definitely equal to 0, but in the third case we also get k equal to minus k. As the point is remaining invariant, the question and the answer should be identical. So we on solving will get 2k equal to 0, so we get k equal to 0. Lastly, write the coordinates of the image of q obtained by reflecting it in the origin followed by the reflection in x-axis. Let us complete this one. So q is going to be firstly written, its coordinate we know is minus 2, 4. Then you are going to reflect it about origin, say we write it as q dash, and then we are going to transform this or reflect it about x-axis. Let's see what answers we get. So reflection about origin, both coordinate sign will change, and when you reflect it about x-axis, only y coordinate sign will change. And if you are observing, now this is your answer, if you are observing, this is an extra information that this change is seen, only x coordinate sign is changing. It is as good as the point is reflected about y-axis. So we have completed all the 4, but we didn't make graph of this. You can take a graph paper, you can plot these numbers, and you can verify these answers. So you have to mark q dash answer on the graph paper, then the reflection, the fourth answer, reflection of this point about origin, and then you will transform it about x-axis again. That can be shown. Let us take one more question. There I will try drawing the graph for you. Let's take one more question. Let us take another board question, 2007 board question. Use a graph paper for this question. The point P 2, minus 4 is reflected about the line x equal to 0, which means y-axis. To get the image q, so can you orally tell what will be coordinate of q? X coordinate sign will change to minus 2 and minus 4 will remain same. Next is find the coordinates of q. That's what we have got. Second question. Point q is reflected about the line y equal to 0, which means x-axis. To get the image r, now you already have q's coordinate. If you are reflecting about x-axis, the y coordinate sign will change, so r's coordinate will become minus 2, 4. That's what they are asking. Find the coordinates of r. Now we are asked to name the figure PQR and find the area of the figure PQR. Let's say we draw this on the graph paper. Now just to save few minutes, I have already drawn it for you, and I'll try putting that figure here. As you can observe, we have marked the points here. P, Q and R. Let's verify whether it's correctly done. P is 2, minus 4, so it comes in fourth quadrant here. This is 2, minus 4. That's done. Then you have Q coordinate minus 2, minus 4 in third quadrant here. Then you have R's coordinate turning out to be minus 2, 4, which is in second quadrant. Minus 2, 4. And you want to name the figure PQR. So if you would have joined these 3 points, you would have got a right angle triangle. So you want to name the figure. The figure is a right angle triangle. So third answer is right angled triangle. And lastly, the fourth question, find the area of the triangle PQR or figure. So area, as you know now, it's a right angle triangle. We can simply use half base height, which is half into base is this length. So this is 2 units on the right and 2 on the left, but because the length is measured, let's not write -2. 2 and 2 will become 4, so base is 4 and height is 4 up, as you have the y coordinate of r is 4 and you have q's y coordinate -4. So let's take 4 down, length let's take it positive. 4 and 4 will become 8. 2 ones are 2 twos are, so answer is 16. And don't forget to mention square units as it is area. So such questions can come for 4 marks. The next question is again a board question. Use a graph paper for this question. 2 centimeter equal to 1 unit. So you will get a graph paper having the width a little longer. 2 centimeters should be treated as 1 unit. ABCD is a quadrilateral. This is a quadrilateral written, whose vertices are ABCD given. First question, reflect the quadrilateral ABCD on the y-axis and name it as A dash, B dash, C and D. Okay, let's start. So when you reflect point A 2, 2 on the y-axis, your A dash will become, so this is mirrored about y-axis, x coordinate will change in sign. So this is A dash value. When you reflect B, B's coordinate is 2, -2. Again about y-axis, then B dash will become how much? X coordinate will change in sign, so B dash would become -2, -2. C coordinate is 0, -1, and when you reflect it to say C dash, its X coordinate sign will change, so that will remain as 0, -1 only, because if you change X to -0, it remains 0 only. And then point D is 0, 1. Let us say they are saying it becomes say D dash, for example. Here to D likha, say D dash, then again it remains same. So both C and D are looking as invariant points to you, as they are not changing in the answer. So after reflection, we want to write down the coordinates of A dash and B dash. In the meanwhile, let me bring the graph for you, so that you start getting how to plot the points and how it will look. Rather, plotting of points, you all know it. Okay, so on your graph paper you must have first marked A 2, 2, which is here. When you reflect it about y-axis, it's going to come here as -2. This was -2, 2. Then you have B coordinate 2, -2, which is here in fourth quadrant. When you reflect it about y-axis, it's going to come here, say as B dash -2, -2. And both C and D remain invariant. Let us say therefore we don't denote extra denotions here. Let's continue with writing C and D only, as the answers are remaining same. Else you will have to write both these points as C dash, D dash also. So better we keep it with a single denotion. Let us look at the question again. The challenge here is only making of graph. That can take you more time. So it's better you practice it, because question is easy, but if you take 20 minutes for this, then the purpose is that you are losing a lot of time. First question, reflect the quadrilateral ABCD on y-axis and name it as A dash, B dash, C and D. So we have named the figure. The reflection of the quadrilateral is over. Write down the coordinates of A dash and B dash. That is also done by us. Name the 2 points which are invariant under the above reflection. The 2 points are C and D points. And now you have to name the polygon A dash, B dash, C, D. So this reflected polygon A dash, B dash, C, D is this polygon that we are talking about. So this is nothing but a trapezium, right? These two are parallel. The y-axis and A dash, B dash lines are parallel. So this is a trapezium. So your fourth answer is quadrilateral ABCD is a trapezium, right? You get 4 marks for this. Let's take one more. Let's keep this as the last question. Say we take the more recent one. We take the more recent question. We take a 2020 question for us. Okay. Question is, use the graph paper for this question. Take 1 centimeter equal to 1 unit on both x and y axis. Plot the points on the graph sheets. So you have been provided 5 points A, B, C, D and E. After plotting them, you have to reflect these points on the x-axis. You have to reflect B, C, D and E on x-axis and name it as A dash, B dash, B dash, C dash, D dash and E dash respectively. Name the points, join the points in order and name the closed figure. So why don't we begin by making directly a graph. So first job is to draw x and y axis, and after completing it, you have to get it reflected. Let us say I have made this and say it looks like this. Okay, just 1 second. All right, so after plotting the points A, B, C, D and E, which I think all of us can manage, A is minus 4, 0, B is minus 3, 2 again here, then you have C 0, 4 here on the y-axis, D 4, 1 is here, and E is how much, 7, 3 is here. Now when you reflect it about the x-axis, this point will remain invariant. This will get reflected here as say B dash, C will become C dash. So their if you are reflecting about x-axis, their y coordinate will change in sign. This is D dash and this is E dash. So plotting is over, reflection is over. Now you have to join the points A, B, C, D, E. So A, B, C. So I'm trying to rejoin it. A, B, C. This is C, D, then E, and then E dash. Right, order is given. Then you have D dash, then C dash, B dash, and then back to A in order. So with scale it will look more clean as it was looking before. This is done. Now you have to name this close-sided figure. Now this close-sided figure is called nonagon. Nine-sided figure, 1, 2, 3, 4, 5, 6, 7, 8, and this is the 9th side. Even if the lengths are not equal, this polygon, just like earlier ones, and this one will be called as nonagon. Earlier ones means like hexagon, pentagon, octagon, 8-sided figure. 10-sided figure is called decagon. 12-sided figure is called duodecagon, DUO. Anyway, nonagon, or this figure also looks like a fish, so you can also call it as fish. I hope so this was a little different. Some students naming it as fish was a little innovative type of thing. both answers are acceptable. So this is the end of your topic reflection, simple and scoring. I hope it is helping you.